Welcome everyone to this session on the real economics of industrial downtime. I'm Santosh Raikar, and today we're going to dive deep into a figure that is often cited in boardrooms but rarely understood accurately: the cost of a single hour of downtime. Our goal today is to shift from simplistic, back-of-the-envelope averages to decision-grade calculations that truly protect your plant's value. When an executive asks what an hour of downtime costs, they aren't just looking for an accounting figure. They're asking about the health of the business. Unfortunately, most plants report a convenient, static number built on shaky assumptions. This isn't just a minor reporting error. Incorrect downtime economics can lead to poor choices in maintenance strategy, staffing, and capital allocation. The core thesis of this presentation is that an hour of downtime is not a universal constant. It is a dynamic value that depends on where the failure happens, what you're making, and how long the recovery takes. By undercounting the hidden costs like margin loss and recovery tails, we miss the opportunity to prioritize the assets that actually drive our enterprise value. To explore this, we'll follow a six-part agenda, starting with why this matters to leadership, moving through common calculation errors, defining what the real cost stack looks like, and finally, providing a practical framework and roadmap for implementing a better model in your own facility. Let's begin with part one: why downtime economics matter. We need to establish why this is a strategic conversation for leadership, not just a technical one for the maintenance department. Downtime is a board-level issue because it directly impacts EBITDA and cash flow. When we understate the cost, we accidentally signal to the board that it's okay to tolerate reliability risks. Conversely, if we oversimplify, we might waste capital on the wrong projects. Leadership needs a number that is economically useful for making tough business calls. To bridge the gap between the shop floor and the C-suite, executives need answers to specific questions. Which assets truly constrain our ability to create value? How does the cost change during high-demand seasons? And crucially, what is the hidden loss that continues even after the green light comes back on? One of the most important concepts to grasp is that not all hours are created equal. A loss at a true bottleneck can destroy significantly more value than a loss in a non-critical area. If your plant uses one average number for the whole facility, you're likely blind to where your real financial risks are concentrated. This accuracy isn't just for show, it drives vital decisions. Operationally, it dictates how fast we respond to a breakdown. For investments, it determines whether we buy a spare motor, invest in predictive monitoring, or redesign a system for better resilience. The cost of downtime is the foundation of our business case. Now that we understand the why, let's look at part two: why most current calculations are fundamentally flawed and where we tend to trip up. The most common mistake is the revenue shortcut. Many plants simply divide annual revenue by available hours. This is dangerous because it ignores the contribution margin, inventory levels, and the fact that losing an hour when you have a warehouse full of stock is very different from losing an hour when you're sold out at the bottleneck. Technical math is rarely the problem. It's the assumptions behind the math. When we ignore downstream consequences and plant context, we generate numbers that are technically accurate but strategically useless. Good costing requires business context, not just spreadsheets. There are 7 key reasons plants get this wrong, ranging from using revenue instead of margin to ignoring the recovery tail. Perhaps most importantly, many fail to distinguish between planned and unplanned events, treating them as if they have the same economic impact, which they certainly do not. Think of downtime costs like an iceberg. The visible costs, parts and labor, are just the tip. Below the surface lie the massive hidden costs: lost margin, scrap, service penalties, and reputation risk. This hidden share is why a minor repair can quietly turn into a major financial event. We must also distinguish between planned and unplanned downtime. Planned maintenance is controlled, buffered, and coordinated. Unplanned downtime is a shock to the system that creates chaos, higher labor costs, and greater downstream disruption. Using the same value for both leads to poor decision-making. While plant-wide averages might be okay for a general orientation, they're too weak for serious decision-making. Best practice requires us to define context-specific values for our most critical assets and major failure scenarios. This leads us to part 3: what does the real cost actually include? Let's look at the complete economic stack of a single lost hour. A true downtime cost is a stack of layers. While repair spend is the easiest to track, lost margin is usually the dominant layer. As leaders, you should always ask what specific categories are included in a cost report before you trust the final number. When we translate an hour of bottleneck downtime into a financial waterfall, we see clearly how value is eroded. This visual bridge helps executives understand why investing in reliability is often a much better deal than just cutting the maintenance budget to save a few dollars. The full stack includes at least 7 categories, starting with lost production at the constraint, moving through labor and materials, and including soft but real costs like utility waste, expedited freight, and long-term reputation risk from late shipments. One of the most overlooked components is the recovery tail. Just because the machine is running again doesn't mean the business has recovered. It may take hours or days for the process to stabilize, for quality to return to 100%, and for the system to reach full efficiency. If we stop the clock the moment the machine restarts, we are significantly undercounting our losses. This is particularly true in continuous processes like chemicals or food production, where restart inefficiency can be more expensive than the actual downtime itself. Finally, we must admit that downtime is context sensitive. An hour lost when the order book is full is much more painful than an hour lost when demand is low. Decision-grade costing requires scenario-based logic rather than a single, frozen figure. This is why the finance department is a critical partner. They help us define the contribution margin, the treatment of fixed versus variable costs, and the true financial impact of lost sales versus deferred production. In Part 4, we'll look at a practical framework. How do we actually calculate a number that is robust enough to be used for decision-making? Step 1 is identifying the true constraint. You must focus on the asset or system that actually limits your saleable output. If an asset isn't a bottleneck, its downtime cost might be significantly lower, and we should prioritize our resources accordingly. Step 2 is defining the context. Was this a total outage or just a partial slowdown? Did it happen during peak season? By specifying these details, we prevent generic numbers from being misapplied to specific problems. Step 3 is quantifying both the direct and indirect losses. Don't just jump to the math. Start by listing the categories of loss, from labor and materials to the harder-to-track startup instability and quality drifts. Instead of chasing one perfect number, Step 4 suggests building scenario ranges. Providing a likely case alongside best and severe cases builds credibility with executives because it acknowledges the inherent risks and uncertainties of industrial operations. Once you have a solid hourly model, you can scale it into an annualized downtime exposure matrix. This converts hourly cost into a value-at-risk discussion, which is exactly the language needed to justify long-term reliability budgets. The final step is cross-functional validation. Engineering knows the mechanics, maintenance knows the repair, operations knows the constraints, and finance knows the money. When these perspectives align, the resulting downtime figure becomes an unassailable basis for action. This checklist serves as your guide. It ensures you're asking the right questions like, does this hit constrained output? And avoiding typical mistakes, such as stopping the clock at restart or using revenue instead of margin. To be clear, simplicity has its place. A simple estimate is fine for general awareness. But when you're talking about millions of dollars in capital or major redesigns, the level of detail in your cost model must match the significance of the decision. Moving to Part 5, we discuss governance. How do we embed these economic principles into our daily management systems so they don't just sit in a drawer? An executive dashboard shouldn't just show downtime hours. It should highlight the economic impact. We want to see the cost of bottleneck downtime, recovery tail indicators, and which bad actor assets are causing the most significant financial erosion. When a board sees an economic dashboard, the conversation changes. It's no longer about, why is the machine broken? It's about, how do we optimize our business system to protect this value? It turns maintenance from a cost center into a value protection strategy. With better data, we can improve our decisions. We can rank our bad actors by their actual business impact rather than just how much noise they make. We can also make data-driven calls on whether we need to invest in redundancy or increase our spare parts inventory. By framing reliability in terms of avoided loss, maintenance can compete for capital on even footing with other departments. A business case built on avoided downtime is much easier for an executive to sign off on than a technical upgrade with vague benefits. Board members should be empowered to ask these 5 questions. They should know what is excluded from the cost model and ensure that the models are being updated as market conditions and process constraints shift. We also need to watch out for common governance failures, like leaving finance out of the room or using a single number for every situation without context. These errors lead to blind spots that can result in massive misallocations of resources. Finally, in part 6, let's look at how to implement this and review some real-world examples of what success looks like. Don't try to boil the ocean. Start with one bottleneck or one critical asset. Refine your methodology there, demonstrate the value, and then roll it out to the rest of the enterprise. The goal is better decisions, not perfect spreadsheets. In your first 90 days, you should pilot a new model on a real event. Align your key stakeholders, finance, operations, and maintenance, and use the insights gained to reprioritize at least one major investment or action plan. Consider this case. A cheap component fails repeatedly. Because the repair was inexpensive, it was ignored. However, because it stopped the bottleneck line, the loss margin was massive. The lesson? Low repair spend does not mean low business cost. In this second case, a restart only took 60 minutes on the log, but it took 4 more hours to get back to quality standards. By only counting the 60 minutes, the plant was drastically underreporting its losses. We must measure the full impact through the recovery tail. In a third scenario, a plant spent capital on a non-bottleneck asset because its average downtime cost looked high. The project was a technical success, but a financial failure because it didn't increase the plant's overall output. Economics must follow the enterprise constraint. Success is achieved when reliability and finance speak the same language. When your bad actors are prioritized by impact and your capital decisions are backed by credible economics, you know you have moved from a reactive state to a strategic one. I'll leave you with 5 takeaways. Move beyond simple averages, focus on the constraint, account for the full loss stack, especially the recovery tail. Get finance involved and use the model to drive better, more strategic decisions. This content was prepared for professional discussion and uses illustrative figures that should be validated for your specific site. You are welcome to quote these concepts with attribution. My goal is to help you turn downtime into a managed business risk. In closing, remember that calculating the cost of downtime isn't just an accounting exercise. It is a strategic capability. When you understand the true value of an hour, you stop managing machines and start managing the economic health of your entire enterprise. Thank you.